As a growing company, GlobalMantics intends to manage a solution like Meraki primarily through its API. To keep research costs down, let's explore the Meraki Public DevNet Sandbox. Let's explore the Meraki API. This is the always-on sandbox, and I'm highlighting the public API key we can use. The username and password are only needed if you want to check out the user interface. Let's switch to the shell. We are going to do 3 successive actions in the getDevices script. First, we will get a list of all organizations. Then, we will get all the networks within the DevNet organization. Last, we'll find the DevNet test network and list all of the Meraki devices inside it. We still import requests for HTTP client operations. More interestingly, do you remember in the previous course where I discussed the 3 pillars of good coding? Those habits weave their way into these demos too. The Meraki get function is an example of functional decomposition. It takes a string resource as an argument and is designed to simplify issuing HTTP GET requests. I'm defining 2 variables, the base API path and the headers dictionary. Per the Meraki docs, we need to use the Cisco Meraki API key header with a value of the public API key from the sandbox page. Here's a snapshot of what the HTTP request might look like, which shows us the required headers. Next, we can issue an HTTP GET request by combining our API path with the resource passed in. We also include our HTTP headers so authentication succeeds. If the GET request fails, we'll raise an HTTP error. This occurs when the status code is 400 or greater. Assuming the request succeeded, we'll return the JSON body back to the caller. Now, let's explore the main function. We immediately employ our Meraki get helper function by getting a list of organizations. The full URL is shown in orange, which is the base API path plus the organization's string. You might be wondering how I knew to use the string organizations. This was outlined in the API documentation shown here in the snapshot. Next, we need to do 2 things together. Let's print out all the organizations, 1 per line. We use a basic for loop to step over all the organizations returned, printing each one. This :6 formatting is just a whitespace alignment technique to keep our name column aligned to the left. We also try to find the organization that contains the word DevNet, and if so, store the organization ID in the DevNet ID variable. Assuming we were able to find the DevNet organization ID, we can get all the networks contained in that organization using our helper function again. This time, we pass in our organization ID along with the word networks, indicating we want a list of networks returned. Here's a documentation snapshot for reference, and you'll notice these URLs are pretty intuitive. Let's use a similar strategy to search the networks for the DevNet-specific network, as there are many other test networks present. We'll print out each network while also checking to see if the word DevNet appears inside. If it does, we'll store that network ID, which is a long string. Here's an example JSON block containing a few networks, which is returned by our helper function. Iterating over this list of dictionaries and accessing data is relatively easy. Assuming we found the DevNet network, we can finally get a list of Meraki hardware devices inside that network. Peeking at the documentation, we feed in the dynamically discovered network ID, then add devices after. We'll use a simple for loop to print them out and include the model ID and LAN side IP address. Here is the JSON structure of the device list that comes back from the Meraki get function. I like the Meraki API because the data structures are generally flat and simple. Let's run the script. Remember that the output will vary regularly as this is a public resource. Scrolling up, we see several organizations, and one of them is the DevNet sandbox with a unique ID. Our code searches the list and finds it, then gets all the networks inside of that organization. Then the code discovered the DevNet always-on read-only network and asks for all the devices inside of that network ID. We end up with 2 devices. These are specific Meraki products currently in use within this DevNet read-only network. In the next few clips, let's look at another technology used for connecting remote devices.